Welcome to Signal Ahead. I'm Alfred. Today's briefing, Quantum Computing. Monday, August 10. This is the synthesis above the noise, not the headlines, but the deep currents beneath them. Let's get into it. Let me tell you what a casual glance at the quantum headlines this summer would miss. If you skim the news, you see a parade of earnings reports. Revenue up 287% here, up 185% there. Record backlogs, fresh listings on Nasdaq, a French firm merging into a shell company to reach the public markets, a Shanghai photonics outfit racing to become China's first listed quantum company. You would come away thinking, quantum computing has arrived. The machines must finally work. But look more closely, and a stranger picture emerges, one that is far more interesting than it works, or its hype. The most non-obvious thing about the state of this field is that its commercial momentum and its scientific maturity have become almost entirely decoupled from one another. The money is flowing, not because anyone has built a machine that reliably outperforms a classical computer on a problem you'd actually pay to solve. The money is flowing because the field has learned to sell something else, proximity to a future that everyone has agreed to believe in. Consider what these companies are actually reporting. When you read that revenue soared, and then read the fine print, you find the growth is driven by system sales, whose timing is lumpy, by acquisitions folded into the balance sheet, by government contracts, by warrant exercises and at-the-market equity facilities that fortify a cash position. One company's revenue was flat for the quarter, and the story was told instead through bookings and backlog. That is, through promises of future revenue rather than present revenue. This is not fraud, it is simply the grammar of a pre-product industry. The number that matters is not what a customer paid for computation delivered, it is how much capital the market is willing to advance against a belief. And on that measure, the belief has rarely been stronger. Now, here is the connection that ties the whole landscape together. Watch where the real customers are. Honda invests in a materials simulation startup. An aerospace and power management giant wins a contract to harden the electrical grid. The Air Force Research Laboratory, DARPA, the National Reconnaissance Office, Canada's Defense Ministry standing up a secure hub in Calgary, the American CHIPS Act dangling a $100 million letter of intent. The buyers of quantum computing today are overwhelmingly governments and a handful of strategic corporates, and they are not buying computation. They are buying insurance and optionality. They are buying a seat at the table for a technology that, if it matures, is too consequential to have missed. That is a fundamentally different transaction from selling a database or a cloud instance, and it explains the peculiar shape of every earnings report you'll read. And yet, and this is the part that keeps me honest, and should keep the skeptics honest too, the science underneath is genuinely, quietly extraordinary. Not the press releases, the laboratory work, a 2-qubit entangling gate that flags its own errors by converting them into detectable photon losses. That is a real idea about how to make error correction cheaper. Attacking the central problem that makes these machines so ruinously hard to scale. Entanglement generated from sunlight rather than from energy-hungry lasers, entangled photons distributed across 62 kilometers of ordinary metropolitan fiber, some of it strung overhead on poles. A photonic architecture that can reconfigure its own shape to coax interactions out of particles that famously refuse to interact. These are advances in the fundamentals, in coherence, in networking, in the economics of error. They are the things that will, or won't, eventually justify the valuations. So the field right now lives in 2 time zones at once. The commercial clock runs fast and loud, quarter by quarter, keyed to sentiment and government appetite. The scientific clock runs slow and patient, keyed to logical qubits and error rates, and whether you can hold a fragile state together long enough to do something useful. A $4 million grant for a 60 logical qubit trapped ion machine tells you where the real frontier sits, not thousands of qubits, but 60 good ones. And even that is a research ambition, not a product spec. The gap between those two clocks is the single most important fact about this domain today. Every claim you hear should be located on one clock or the other before you decide what it means. Over the next stretch, I want to earn that distinction properly. I want to look hard at whether the modular approach, abstracting hardware away behind software, orchestrating across a dozen simulators and a scattering of real machines, is a sign of maturity, or a way of papering over the fact that no single machine is good enough yet. And I want to ask the uncomfortable question that the earnings euphoria is designed to postpone. What happens to all this belief when the science clock and the money clock finally have to agree on what time it is? Because they will. They always do. If you spend enough time reading the quarterly financials of quantum computing companies, a curious thing happens. The numbers start to blur, and what remains is a shape. And that shape, I'd argue, is the real story, more than any single revenue figure or qubit count. Let me try to describe it. On the surface, we have a great deal of noise. One company reports flat revenue because a system sale slipped from one quarter into the next. Another posts a figure up, a startling 185% year-over-year. A third soars nearly 300% and raises its guidance for the year. These numbers seem to be shouting at cross purposes. If you were trying to read the health of the field from any one of them, you would come away either euphoric or despondent, depending on which press release you happen to pick up. That is precisely why we should not read the field from any one of them. Beneath the volatility, notice what is actually accumulating. It isn't primarily revenue. Revenue in this sector remains modest, lumpy, and hostage to the timing of a single machine changing hands. What is accumulating is commitment, backlog, bookings, long-term enterprise engagements. When one company reports that its quarterly revenue was flat, but its backlog expanded dramatically, that is not a contradiction. That is a signal. It tells you that the buyers of these systems are no longer making one-off experimental purchases. They are entering into extended relationships. A record backlog is a promise about the future written in the present tense. And when several companies report the same thing at once, surging bookings, record backlogs, guidance raised, you are no longer looking at a fluke of accounting. You are looking at a deep current. Consider where the money is coming from, because provenance tells you about permanence. A car maker invests in a materials science algorithm startup, not as a charitable gesture toward the future, but because it wants next-generation materials and has concluded that this is a plausible route to them. A defense research laboratory writes a $7 million contract to harden the electrical grid. A national government stands up a secure innovation hub. A space intelligence office and a defense agency extend contracts for atomic clocks and precision timing. These are not speculative bets placed by people hoping to catch a wave. These are institutions with long planning horizons and low tolerance for fashion, deciding to build the capability into their infrastructure. When Honda, an Air Force, and a National Defense Ministry all arrive at the same conclusion within the same fortnight, the conclusion is doing more work than the coincidence. And then there is the migration to the public markets, which is perhaps the most telling structural fact of all. A French neutral atom developer completes its combination and clears the regulatory hurdle to list. A European firm files its first earnings as a newly public company. A photonic firm in Shanghai begins the formal tutoring process to become its country's first listed quantum company. Going public is not a technical achievement. It is a declaration that a business believes it can survive the merciless quarterly scrutiny of ordinary investors. It drags a formerly cloistered science into the daylight of balance sheets and guidance and warrant exercises. That is a maturation ritual. It is the field agreeing to be judged by the same instruments we use to judge airlines and grocers. But here is the subtlety I want to hold on to, because it complicates the triumphant reading. The commercial momentum is running ahead of the physics, And the physics is precisely what the momentum is a bet on. In the same span of days, we see a modest $4 million grant to build towards 60 logical qubits, an entangling gate that announces its own errors as detectable losses of light, an architecture that reshapes itself to coax photons into interacting. These are foundational, unglamorous, genuinely hard problems in error correction and qubit control. They are years, not quarters, from resolution. So the deep current has two channels running in parallel: capital committing on business timescales and error correction advancing on scientific ones. The bet embedded in every record backlog is that the second channel arrives before the first runs dry. What I find most instructive is the emergence of a middle layer between them, software that abstracts the hardware away, so an application need not know which machine it lands on, orchestrators that choose among a dozen simulation methods, or dispatch to a real processor. Hybrid workflows pairing classical modeling with quantum measurement to compute the behavior of a genuinely difficult molecule. Even executive certificates teaching non-technical leaders how to source and procure quantum capability. This is the connective tissue of an industry, not an experiment. The plumbing, the middlemen, the training courses. You do not build procurement strategy around a physics demonstration. You build it around something you expect to buy for decades. So the trend beneath the noise is this: an industry assembling its skeleton, markets, contracts, backlogs, software layers, trained buyers around a scientific core that has not yet fully hardened. The structure is real. Whether the physics fills it in on schedule is the question we carry into what comes next. So we have spent our time together looking at a rather remarkable 8 days in the life of this field, and it falls to me now to ask what all of it actually means, not the headlines themselves, but the shape they trace when you stand back and let your eyes go soft. Here is the first thing I would have you notice. If you tallied the money flowing across those 8 days, you would find it arriving from an astonishing variety of directions. A car maker putting capital into a materials algorithm startup. An electrical power company winning a defense lab contract to harden the grid. A photonics firm queuing up to become the first of its kind to list publicly in its country. A trapped ion company reporting revenue nearly quadrupled year on year, and another superconducting outfit reporting its own surge alongside a $100 million letter of intent under an industrial policy program. And a steady drumbeat of firms going public by one mechanism or another: the reverse mergers, the special purpose vehicles, the dual listings across 2 exchanges. What this tells you is that quantum computing has quietly crossed a threshold. It is no longer purely a science story funded by patient grants and national pride. It has become a capital market story, which is a very different animal with a very different metabolism. And that shift carries a second-order implication I would ask you to hold on to. When a technology becomes a public markets phenomenon before it becomes a settled product, you get a peculiar pressure. The companies must now narrate themselves quarter by quarter, backlog, bookings, guidance raised to an audience that thinks in 3-month intervals, while the underlying physics still thinks in decades. Watch that tension. It produces genuine acceleration, because capital is oxygen, and these firms are now breathing freely. But it also produces the temptation to dress up a demonstration as a deliverable, to let the word record do the work that useful has not yet earned. The discerning observer learns to read past the revenue line and ask a quieter question: what can this machine actually do today that a classical computer cannot do better and cheaper? Which brings me to the second thing worth noticing, and it is the more hopeful one. Underneath all the financing theater, the actual engineering is moving in a direction I find genuinely encouraging, toward modesty, toward integration, toward honesty about limits. Consider the workflow that paired a quantum machine with a battalion of graphics processors to compute an interaction energy for a complicated enzyme. The quantum part did not swagger in and solve everything. It took the one slice of the problem where it might plausibly add value and left the rest to classical hardware that already does that work superbly. That hybrid posture, the middleware layers that abstract the hardware away, the orchestrators that decide when to simulate on a processor and when to dispatch to a genuine quantum device, is, I think, the true signal in all this noise. It is the sound of a field growing up and admitting that the future is not quantum replacing classical, but quantum threaded carefully into the classical fabric where, and only where, it pays. Then there is the error problem, which remains the great gatekeeper. A 2-qubit gate that flags its own mistakes as detectable photon losses is exactly the kind of advance that never makes a stock jump, but quietly moves the whole enterprise forward, because it lowers the crushing overhead of error correction. And on the horizon, funding for architectures aiming at scores of logical qubits. Logical, mind you, the corrected and trustworthy kind, not the raw and fragile kind. Keep your eye there. Logical qubits are the currency that matters. Physical qubit counts are the vanity metric. Now let me draw the strands together, because the third implication is the one that reaches beyond the field itself. Notice how much of this activity clustered around sovereignty, a nation standing up a secure defense hub, agencies buying post-quantum networking, contracts for atomic clocks and grid resilience, and the race to plant a national flag on the first public listing. Quantum is becoming an instrument of statecraft, and that changes the incentives yet again. It means the technology will be pulled forward by security anxiety as much as by commercial promise, and those two engines do not always steer in the same direction. So what should you watch as we close? 3 things. Watch whether the hybrid, integrated approach keeps winning over the moonshot rhetoric that tells you the field is maturing. Watch the logical qubit and the error-flagging gate, not the press release numbers that tells you the physics is delivering. And watch the money's mood, because a field newly dependent on public capital is newly exposed to public sentiment, and sentiment is fickle in a way that fault tolerance is not. The dying boy in the old ballad mistook a wisp of fog for a king. Our task in this strange and promising moment is the reverse, to tell the fog from the thing that is genuinely, quietly arriving. Until next time, do keep looking ahead. That's the signal for today. The noise will keep coming. We'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.